Hi, I'm Michael with Tarrant County College, and today we're going to talk to you about density. So what is density? Well, if you read a book, a textbook that is, it'll probably say something like, density is defined as the amount of mass in a given unit of volume. True enough, but if you're like me, you're not totally satisfied with that answer. I like to think of density in terms of a suitcase. Say you're packing for a trip, and you want to leave some extra space in there for the souvenirs you plan to bring back with you. As a result, the suitcase is not that tightly packed, or it is less dense, you might say. However, on your way back from vacation, you have stuffed your suitcase with every possible souvenir known to man. Not to mention all the stuff you brought with you in the first place. You had to have two people sit on the suitcase just so you could close the zipper. You might call that suitcase very dense now. So that's basically what density is. It's how tightly matter is packed into a given unit of volume. Things that are less dense, like wood, will float on things that are more dense, like water. Air that is less dense, like hot air, will rise above and float on air that is more dense, like cooler air. That is, of course, the principle behind hot air balloons. So as you can see, density can be used for all sorts of cool things. Now let's get to the calculations. Here's a good example. Suppose we have a cube of osmium metal, 1.500 centimeters on a side, which has a mass of 76.31 grams at 25 degrees Celsius. What is its density in grams per centimeter cubed at this temperature? The first thing we want to do is write down the equation. Density is equal to mass divided by volume. Now that we know the equation, we should list out our variables to see what we know and what we don't know. We can find the values for these variables by looking in the problem. The question is asking me for what the density is, so I don't know that one yet. I can put a question mark in front of that one for now. The mass is given to me as 76.31 grams, so I can write that one down here. Now, here comes the tricky part. If I look carefully, I realize that this problem does not give me the volume. So what do? Well, I am given the length of a side, 1.500 centimeters. We also know that the object is a cube. How do we find the volume of a cube? That's right. We take the length of the side and cube it. There we go. 3.375 centimeters cubed. We'll keep all those numbers since we started with 4 significant figures to begin with. We now have mass in grams and volume in centimeters cubed. These units match the units we want for our answer. So we can now plug our values into the equation and solve. And there we go. 22.61 grams per centimeter cubed. Wow, that's twice as dense as lead. Let's try another problem. This problem tells us that the density of benzene at 15 degrees Celsius is 0.8787 grams per milliliter. Calculate the mass of 0.1500 liters of benzene at this temperature. We can begin this problem the same way that we did the last one. We can tell it is a density problem, so we know we need the density formula. We also need to list out our variables to find out what we have and what we don't. Just like before, we can find out what we have by looking at the problem. In this case, the problem asks us to calculate mass. Therefore, we can put a question mark in front of that one since that's what we're trying to find. Density, however, is given this time, 0.8787 grams per milliliter. So we can put that here. Fortunately for us, the volume is also given, 0.1500 liters. But let's take a closer look here. If we compare the units given for the density and the volume, they don't match. Density is given in grams per milliliters, whereas volume is given as liters. We won't be able to get the right answer if we put these values into the equation just like they are. So what do? Well, we have a couple options actually. We could A, convert the volume from liters to milliliters, or we could B, convert the density from grams per milliliter to grams per liter. I usually prefer to convert the simpler units, so we'll just convert the volume to milliliters. To do this, let's start with our given value for volume, 0.1500 liters. Then, we can multiply it by our conversion factor. Since we don't actually know what our conversion factor is yet, we can just draw a blank one here. When using conversion factors, we want to figure out which units go on top and bottom first. The unit that should go on the bottom is the one we want to cancel. In this case, liters. The unit that goes on top is the one we are converting to. In this case, milliliters. Now that we have our units, we need only to remember that a conversion factor is simply a fraction where the top is equal to the bottom. So, how many milliliters are equal to a liter? That's right, 1,000. Now, all we have to do is multiply the numbers on top and divide by the numbers on bottom. There we go, 150.0 milliliters. We can now solve our equation for mass. If we multiply both sides of the density equation by volume, we get mass equals density times volume. Now, all we have to do is plug in our numbers and solve. And the answer is 131.8 grams. Well done. Now I have a secret to tell you. There is another way to solve this problem that is both quicker and easier. The catch? Well, you have to use conversion factors. You see, whenever you are given density or any other value with a fractional unit, you can break it into a conversion factor like this. The 0.8787 grams per milliliter is actually 0.8787 grams over 1 milliliters. You can use this to convert from milliliters to grams or from grams to milliliters, whichever you need. So let's see how you would set this up. First, you have to start with a value that is not a conversion factor. Also remember, since conversion factors are fractions, where the top is equal to the bottom, they do not change the amount of something. They only change the unit. This means that what you start with should in some way be equal to what you are looking for. I'm looking for the mass of what? That's right, 0.1500 liters of benzene. The mass I get will be equal to that volume. So I start with the 0.1500 liters of benzene, and I will set up my first conversion factor with liters on the bottom, so it cancels out. I can't use my density as a conversion factor yet, since I have liters and not milliliters. So I'll just convert from liters to milliliters first. 1,000 milliliters equals 1 liter. Okay, so I now have milliliters, but I'm looking for mass, so I need to keep converting. Since milliliters is now on top, I'll need to bring that down to the bottom of the second conversion factor. Now for the top of that conversion factor. What can I convert milliliters into? That's right, grams. The density can help me here. I have 0.8787 grams for every 1 milliliter of benzene. I now have grams on top of my conversion factor, which is what the question is asking for. So I can stop converting here. All I have to do now is multiply the numbers on top and divide by the numbers on bottom. And I get 131.8 grams, just like before. Now, for some of you, using the density equation might be easier. For some of you, using conversion factors will be easier. You should use whatever makes more sense to you. I hope this video helped you and made you all love density. Well, at least made it easier. Thanks for watching. Please feel free to email me with any questions at michael.depow@tccd.edu or come by and see us at the Science Learning Center at Tarrant County College's Southeast Campus. Have a great day.